Hi everyone, welcome back to this channel. So today we are going to talk about another topic, which is load balancing. And it's also a very important concept in distributed systems, which is for high availability and high scalability. So let's talk about the background of load balancing, okay? So in previous sessions, we talked about in order to have high scalability and high availability, we need multiple servers to serve users' request, right? No matter it's internal request or external request from real users, okay? So we will have multiple servers here. So let's see, we have 5 web servers here to serve the user's request, okay? Let's assume it's Google servers, right? So which serves request from the www.google.com, okay? So here we have 5 servers to achieve high availability and high scalability, okay? So, and we talked about when user requests come to the system, the request will be distributed into the different servers, right? So for example, for user A's request, maybe it will be distributed to this server based on consistent hashing or maybe any other mechanism, right? And also for user B's request, it could be routed to this server, right? Okay, so this is what we have talked about in previous sessions, right? Which we serve request with multiple servers. Okay, so this is server, right? And we also have client, okay? So client here, let's say you typed in 3w.google.com and you have a search request, and it will be, the request will be served by one of the 5 servers, okay? So now the problem is, how does the client, okay, so how does the client send the request to one of the servers, right? So how does the client know which server I should send the request to? Okay, and what's the mechanism I should use to choose a server, right? So if you consider about it, there are 2 possible solutions here, right? So solution 1 is, let's just expose all servers, all web servers to client, and client choose the server to send request to based on some mechanism, okay? So this is the solution 1. What does this mean? This means, okay, let's say we have 5 web servers to serve request, and we will expose the IP addresses of all these 5 web servers to the client, to all the clients, okay? And then client knows the IP address of these 5 servers. And then based on some mechanism, the client can decide, oh, for the current request, I will send the request to server 1, or I will send the request to server 4, okay? So the client does everything, right? So what's the problem with this approach? So with this approach, you can say, okay, we have to expose all our servers to client, right? So once you expose more things to client, to outside of the world, then it's insecure, right? So because you're exposing more information to external world, and maybe it's unnecessary information you are exposing, right? So this is the first problem. The second problem is that the client must be intelligent, right? So because, yes, the client now knows all the web servers addresses. Okay, so I must have some intelligent way to know for the current request, which server I should send the request to, right? So it's an intelligent client, right? And more importantly, or more worse, the things make it worse is that the clients should only care about business logic, right? So for example, if I am Google, okay, so if a Google client, The only purpose of the client, the only thing the client should care about is that I just send a search term to the system, to the Google's website or Google servers, right? You give me the result. This is the business logic I only care about, right? I don't care about how many servers you have, what are the IP addresses of your servers, right? Those are the scalability details that Google should handle rather than the client should know or should handle, right? So this is the second problem. The third problem is that, let's say you are using a browser or something, okay? And you never visited Google before or some server before. How do you know all the IP addresses of all those servers? How do you get those information, right? So that's another thing which makes it more complex, right? And we're not only talking about one server, right? Maybe for Google, they have thousands or tens of thousands of web servers to serve search, right? So how does the client know all these tens of thousands IP addresses? And is it possible it can store all those tens of thousands IP addresses on client or in the browser? I don't think so, right? So this is the third problem. And then the things which will make it more complex is, what if some servers has failures and some new servers have to kick in? How does the client update the addresses of the new servers and deprecate the dead ones, right? So if you think about it, so this makes things super complex, right? So especially the client should not care about the scalability things, because multiple servers is for scalability and availability, right? Client should assume the Google system or our system should always be online and can always serve requests, right? It shouldn't care about how we achieve it, right? So we shouldn't expose so many details to the client. So these are all the problems for this solution, okay? So what other solutions do we have? Another solution is, let's say, in front of all these servers, okay, we have just a single server, okay? So this single server is the single, okay, so let's say solution 2, okay? So let's erase this. So now solution 2 is only have one server to receive client requests. And this server is the single point of contact for our between client and backend servers, okay? So this is our solution 2. So, okay, let's go into more details of this. So here we will have one single server. So we only expose one IP address to the world outside our system, okay? So when client send request, it only needs to know one IP address, and it only send request to this single server, to this single IP address, right? And then this single server is intelligent, and this single server from our side will decide how to distribute the current request from client to one of the servers we have, to one of the web servers we have, right? So in this method, you see this single point of contact. It is called load balancer, okay? So now I will use a different icon for this. So this is called load balancer. So this is called the load balancer. How does it work? So client will send the request to this load balancer, and client only knows about this load balancer, okay? And then this load balancer internally will decide how to route the request to different servers internally, okay? So this is how it works. You can see here, client doesn't need to be intelligent, right? And also it doesn't need to know we have multiple servers, right? From client's perspective, we only have one server, which is a load balancer, right? And it doesn't need to choose which server to send the request to, right? Because it's only one server, which is load balancer. And all the complexity of choosing which server to send it to, how to update the current servers when some servers die and when some new servers kick in, right? So all the complexity is now in our load balancer, right? So client is simple now. So this is solution 2, which is load balancer, okay? So now we introduced the load balancer, okay? And that's why we call this section, we call this video load balancing. It's all about this load balancer, okay? Okay, so cool. So we talked about the background of load balancer, why we need it, right? Comparing to the alternative solution, okay? Cool. So why, another thing I want to mention is why it's called balancer. What does it balance? So obviously it balances all the requests sent to our system, right? It needs to, ideally, it will evenly distribute all the traffic to all the web servers, assuming the web servers are the same, right? So now let's talk about some algorithms or some mechanisms we could use to balancing the request coming from client, okay? So what mechanism could you think? Okay, so let's say the current topic is problem, how to do traffic balancing, okay? Okay, so the first mechanism is very simple, right? You just randomly choose a server, okay? So let's say you have a random function which can generate numbers between, let's say, 0 to 99, okay? And you have 5 servers, right? So when a request comes, you just do some random hashing, okay? So let's say you can hash the request based on its IP address, or you can hash it based on the actual content of the request, right? And then you just randomly choose a number or randomly choose a server to send the request to, right? Based on some random number. So in theory, it should work, right? Because you just randomly send it to servers. So in theory, when the traffic amount is big, it should be evenly distributed into all the servers, right? Okay, so this is a random algorithm. So the second algorithm is round robin. What does this mean? Okay, from the name you can guess, right? So it's just sequentially send the request to all the servers based on the round, right? So for example, for the first request, I will send it to server 1. For the second request, I will send it to server 2. For the fifth request, I will send it to server 5. And then for the sixth request, I send it to server 1 again. So it's a round and round and round, right? So this is why it's called round robin. So this is a second scheduling or second balancing algorithm, right? And we also have a third algorithm, which is called least connections. Okay, least connections means, let's say, okay, so let's say this server 1 currently is serving 1K request, so it has 1K pending request to process, and this server has 1.2K request. Currently it's processing, okay? And this server now it has about maybe 0.8K request outstanding, okay? And now this one has 0.75K, and this one has about 2K request being processed, right? So least connections or least pending request mechanism is it chooses the server which is currently processing the least request or has the least connections with client, right? So in this case, you can see this server 4 only has 0.75k request, pending request processing, right? So it's the smallest number, right? So then for the next request, we will just send it to this server, okay? So this is a least connections or least pending request algorithm to balancing the traffic, right? And another related one, which you could think of, is the least response time, right? So it's, let's say, so this server, yes, it handles request on average. It takes about, let's say, 3 milliseconds to process a request. This server takes about 500 milliseconds to process a request on average, okay? So let's say this server takes about, let's say, 1.2 seconds to process, and this takes about 100 milliseconds, and this takes about, let's say, it's also 500 milliseconds, okay? So in this algorithm, least response time, we will send the request to the fastest server, or to the quickest server which can have a fast response, right? In this case, it's this 100 millisecond server. So we will send the next request to this server, okay? And as you can imagine, when this server receives more and more requests, it has more and more pending requests to process, right? Then the average processing time will begin to increase, right? So maybe at some point it can increase to about 400 milliseconds, right? And then once it became 400 milliseconds, you can see the least response time comes from this server 1 now, right? So then for the next request, we will just send the request to server 1. So this is the least response time method, okay? And the next one, which we introduced actually in our previous sessions, right? Which is called hashing, okay? Especially we talked about especially for database scenarios or database environment, the very common technique to use is consistent hashing, right? So here you can also use consistent hashing, right? So for example, when a request comes into our system, you know its IP address, right? Or you know the user ID, or you know some other information. So you just take one piece of the information. Let's say you take the user ID, okay? And then you just map the user ID to some numbers, right? And then based on consistent hashing algorithm, then you can choose one of the servers to send the request to, right? And with this, for a specific user ID or for a specific IP address or any information you take to hash, right? So for the same number or for the same user ID, it will always be routed to the same server, right? So this is an advantage of this hashing algorithm. While for others, for example, for least response time, maybe for the same user, maybe for this request, it will be routed to server 4, but for the next request, it can be routed to the different server, right? So in most cases, especially for web servers which directly receive client request, there's no problem you send it to different servers. But for some scenarios, you want to always send to the same server, right? Because that server, maybe it stores some state which you want to leverage, right, for the request. Okay, so this is the advantage of this hashing mechanism. Okay, cool. Okay, since we talked about this hashing thing, and let's talk about another concept or characteristics of load balancer. Okay. So there are two types of load balancer, or two features, right? Or two different features. One, so they are sticky session and non-sticky session. Okay. So what is sticky session? So if a load balancer supports sticky session, okay, then the request coming from the same client will always be routed to the same server. So let's say the client, let's say for this single client, which is from user 1, okay? So when this client sends a request to the load balancer, this client's request will always be routed to, let's say, server 1, okay? So this is called sticky session because the request will always be routed to the same server. And the advantage of this sticky session is you can store some information, store some state on this server, and this state can be shared by all the requests from the same client in the same session, right? So this is called sticky session. So what is non-sticky session? Non-sticky session means there's no deterministic way to send the request, right? So even for the request from the same client, from the same user in the same session, okay, the request could be routed or could be distributed to different servers. So let's say at time 1, my request comes into the load balancer and it will be sent to server 1. And for my next request, which is request 2, maybe it's request 2 is sent just after request 1. Maybe it's only after 1 second, okay? Still, it will be routed to a different server. So there's no guarantee your request will be from the same user or from the same client will be routed to the same server, same web server, okay? So this is called non-sticky session. And you can, and of course you can think, okay, for non-sticky session, you definitely don't want to store state on the server, right? Because there's no guarantee the next request will be sent to the same server. So there's no way you can reuse the state which you stored previously on this server, right? So this is the difference, okay? Cool. Okay, so we talked about what is load balancer and how to do traffic balancing and two important concepts for load balancer. One is sticky session and one is non-sticky session. Okay, so this is the content from this video. Okay, so in the next video we are going to continue to talk about load balancing, but in the DNS environment. Okay, so see you in next video. Thank you, and don't forget to subscribe to this channel, and thank you for your support always. Okay, cool, see you.